Alrighty, hello, my name is Sam Mallard, and today I'm going to be doing a presentation on the hydroelectric power analysis. One second, let me get this set up. From the beginning. Alrighty, let's share. There we go. All right, now that we can see this, this is the hydroelectric power analysis by me, Sam Mallard. Um, oops. What is my research question? How much water? My research question is how much water does Wilson Dam release per hour? What is the elevation difference? And is there a specific time of day with the most outflow? So to collect and compile the data, you have to obtain the data from TVA Dam's website. The data itself had to be converted into an Excel file. The data had the time, day, which is April 24th, 2024. It had the hourly discharge, which is cubic feet per second, the reservoir height, and the tailwater. And basically, these data will just help us define the data and the itself. So to compile this data, um, we had to put in specific geographic coordinates. So I used latitude and longitude points to put in an Excel table. I also used Google Maps just to get points from the dam or for the dam anyway. So to collect and compile this data, we had to plot the point on the map by using XY, display XY data. My location was unable to geocode because it is a road instead of like a single place, like a house. It stretches for longer than the dam itself. Anyway, the result of this gave me 24 points with the time step along the dam. So in the methodology I used to get all this information was I used a symbology to symbolize each hour or to symbolize what the spillage was. The field, I had to calculate field for specific ones. I used the timetable feature and select by attributes. So the results for this are as follows. So this is the Wilson data itself. This is the hourly discharge of cubic feet per second. And it goes from 7,000 to 27,000. You can see already, like later in the day, uh, starting about 10 o'clock a.m., well, 10 o'clock, all the way up to 11 p.m. or 2300. And that's how much the Wilson Dam releases per hour for cubic feet per second. And then so I wanted to figure out what is the gallons, how much they released per hour by gallons. So the formula was 60 times 60 times 7.481. And there is 60 seconds in a day, or 60 seconds in a minute, and 60 minutes in an hour. And that is the hourly. And then 7.481 is just the how many gallons are in a cubic feet of water. And then we went to elevation difference. Oh, sorry, I went too quickly. This went all the way from 200 million all the way to 740 million. And there's a big difference between the hourly discharge, and I had to do unique values because this is how I calculated my field. The elevation difference is the same thing. I had to use calculate field and then tailwater minus reservoir or reservoir minus tailwater. I do not remember. So the elevation, you can see that it doesn't really change all that much. There's a few times throughout the day where they like at 5 o'clock it was higher. It was at around 93. Like the higher 93, nearly 94 feet of a difference, or 93 inches of a difference rather. And then I wanted to show the attribute table as well because you can see the reservoir and the tailwater. So all the way from 506 to 413.84, and that's the elevation difference itself. And then the highest slope per day, I used select by attributes, and I did 15,000 with 15,000 for the hourly discharge. This is cubic feet per second. That is important to note. And we can see that about 10 o'clock, how I've already mentioned, around 10 o'clock is whenever it kind of starts getting higher and higher. And that is bad. It goes all the way from 27, it goes like all the way to 27,000 cubic feet per second later in the day. So you can see kind of later in the day, they spill more. And it's also important to note that there was no rain on the 24th of April. So before I start my conclusion, I want to share my Wilson Dam project itself, because I had to you'll see here that basically it's going to be like the time feature, and I wasn't able to put this into the PowerPoint, but you can see throughout the day it kind of has the hourly discharge and picks up around 10 o'clock, and then around 3 and 4 it stops again, and then goes up around 4 again. I'll do this one more time just so you can see it. And you can see it just kind of making its way, and then again around 10 o'clock. And then it's just higher from here until about the next day. And that is about how much hourly discharge there is. Anyway, now let's share my PowerPoint. Now, in conclusion, what we learned about this project is that TVA spills Wilson Dam later in the day rather than in the morning. And then we also learned the amount of water spilled per hour. We also asked a question like, is there a difference in elevation? And there's not much of one to begin with. So TVA can basically use this data to see how much energy they produced, as well as perform other analyses for comparison with other dams in the region, like Gunnersville, or I think Gunnersville. And there's also Wheeler Dam, and those are some just in North Alabama that I can think of. You can also compare to see if they're around the same, if they're in relatively the same size. They're both situated off the Tennessee River. So that is one version of this. Thanks for listening, and here's my references. One of them is from this is how I got my data, the TVA environment lake levels for Wilson Dam, and how to help me with mapping of overview of time. Alrighty, and then that is everything. I'm going to end this meeting. I hope you have a great rest of your day. All right. Let's try this again. Have a good one.